The kit is intended for the detection of SARS-CoV-2 RNA by reverse transcription and polymerase chain reaction. There are three targets: the two loci of genes E and N specific for SARS-CoV-2, and a conservative loci of gene E common for SARS-CoV-like coronaviruses, including SARS-CoV and SARS-CoV-2. This technology improves reliability of diagnostics by allowing to consider the possible accumulation of mutations in viral genome and lowering the risk of false negative results. The usage of RNA internal control allows avoiding mistakes on the stage of RNA extraction and amplification. Attention, the RNA-IC reagent is included in the amplification kit, but is used on the stage of RNA extraction. One-step technology employs reverse transcription and polymerase chain reaction in one tube, and allows to optimize the workflow and save the time. The technology of hot start and covering of master mix with paraffin layer is employed. This improves the specificity of reaction through the implementation of hot start feature, and significantly reduces the risk of contamination with amplicons, which is particularly important in high-performance workflows. The kit is adapted for detecting thermocyclers of DT series, DT Lite or DT Prime real-time thermal cyclers made by DNA technology. Software for detecting thermocyclers of DT series automatically forms specific reports with the conclusion and interpretation of the results. The kit contains two parts: the reagents and TAC-RT enzyme. The main part of the kit is stored from 2 to 8 Celsius and out of light, and TAC-RT enzyme at temperatures from -18 to -22 Celsius. The kit contains paraffin-sealed PCR mix, enzyme TAC-RT, RT-PCR buffer, internal control RNA-IC-A, positive control sample, and tube leads. The kit is intended for 96 tests, including positive and negative control samples. Mark the required number of the tubes with paraffin-sealed mix according to the number of samples to be analyzed, and one tube for negative control, C-, and one tube for positive control, C+. For example, to test 8 samples, mark 8 tubes, one for each sample, one for C- and one for C+. The resulting number of the tube is 10. It is recommended to mark the upper third of the tube. The cap of the tube cannot be used for marking. Prepare RT-PCR buffer and enzyme. Attention! Enzyme TAC-RT should be got out of the freezer immediately prior to use, and return in the freezer after addition. Vortex the RT-PCR buffer and the enzyme thoroughly for 3-5 seconds, then spin briefly for 1-3 seconds. Calculate the volumes of RT-PCR buffer and the enzyme TAC-RT. For RT-PCR buffer, multiply 15 microliters on the number of the market tubes, which is 10, with the excess of 1. For 11 tubes, this is 11 multiplied by 15. The volume of the RT-PCR buffer is 165 microliters. Volume of the enzyme is calculated in the same way. Multiply 0.5 by 11 tubes. Volume of the enzyme is 5.5 microliters. Prepare a clean 1.5 milliliter tubes. First, add the required volume of the buffer. Next, add the enzyme. Attention! Taking the enzyme, it is necessary to dip the tip no more than 1 mm, and observe the rules for dosing viscous liquids. Vortex the tube with the mixture for 3–5 seconds. Then spin briefly for 1–3 seconds. Add 15 microliters of the RT-PCR buffer and the enzyme mixture into each tube. Avoid paraffin layer break. Close the tube slightly. Before next step, put all the kit components except positive control sample in the refrigerator. Prepare RNA samples. Add 10 microliters of the RNA samples into corresponding tubes. Do not add RNA into C- and C+ tubes. Avoid paraffin layer break. Add 10 microliters of negative control sample, which passed all RNA extraction procedures, into corresponding tube. Add 10 microliters of positive control sample into corresponding tube. Close the tubes tightly. Spin down the drops on vortex for 3–5 seconds. Put all the tubes in the block of detecting thermocycler and run RT-PCR. Start with the amplification program for RT-PCR. Open the real-time PCR program in the device operation mode. For the first RT-PCR run, upload SARS-2 SARS RNA IC INI file. You can download INI files from DNA Technology site. All amplification settings will be uploaded in the thermocycler automatically. For next runs, add the test SARS-2 SARS RNA IC to the protocol. Positive and negative controls are loaded as samples. Mark the position of the tubes in the thermocycler thermoblock according to the way they are placed in the thermal unit. If it is necessary, change sample identifiers. Push the button Apply. Run the amplification program. The next step is forming of the specific report. To input information in the specific report, do the following. Put the check mark in the field Conclusion. Press the button I, Information. Enter the personal data of a patient. Press the button Apply. The text of the conclusion will appear in the specific report. Now the specific report can be printed. The interpretation of the results is described in the full instruction for the kit. In case of positive signal in all 3 channels, according to the instruction, The conclusion must be the RNA of SARS-CoV-2 is detected. In case of positive signal only in farm channel, the conclusion must be the RNA of SARS-CoV-like viruses is detected. The RNA of SARS-CoV-2 is not detected. In case of negative result, the signal only in hex channel is present, that corresponds to internal control. There is the possibility of detection only one SARS-CoV-2 gene, in or N. This can be due to low virus load in the sample. In this case, repeating sample taking is recommended. Positive result on farm and ROX or CY5 channels that corresponds to specific loci of SARS-CoV-2 genome can be due to mutation in one of SARS-CoV-2 genes. The absence of positive signal on all three targets and IC is an unreliable result. Unreliable results can be caused by different problems and requires repeating the sample analyzing.